Okay, we're going to start on page 23 in your packet. Just copy down the definition of log base 10. We'll pause the video here for you to do that. So anytime you see a logarithm without a base, it is a base 10. So we can evaluate all of these, A, B, and C, because what A is saying is 10 to what power is 1,000. If you don't know off the top of your head, what we could do is 1,000, if we rewrite that as a 10 to a power, that's 10 to the third, so this is 3. For B, 10 to what power, instead of writing 0.01, I'm going to make that 1/100th. And then to make the bases the same, this is 100 to the -1 to make it not a fraction. And then 100 is 10 squared. We can multiply these exponents, so that is -2. And then 10 to what power is -3? Well, we can't make -3 into a base of 10. Well, we could use our calculator to evaluate this because there is a log button, or we could look up here. It's not defined if x is negative. This is negative. So there is no answer, does not exist. For a log base e, that is ln, or the natural log. So you can copy down that definition. And now we can have a shortcut for number 2. I'm sorry, for A. Because ln and e are the same base, we can ignore them and get a value of 3. Well, here's why that works. If we say the base e to what power is e to the third, just like we did up here when we said the base 10 to what power is 1,000. Well, that what power is 3. So for B, e to what power is 1/e squared. To make that not a fraction, I'll make the exponent negative, so that power is -2. Now for C, e to what power is 5? I don't know that. You can use your calculator. You have to use your calculator to evaluate it. So you can type the ln button. And if you type that in your calculator, you should get 1.609. Okay, so all the properties we did yesterday apply for ln, or log base 10. So when you have a product of the argument, we can separate that with addition. When you have the division of the argument, we can separate it with subtraction. This power becomes the coefficient. The ln of e to the x, this is a special property. Because the base of ln and this base e are the same, we get just the exponent of x. The same thing works for e, because we have e to the power of ln, which is the same base as e. We get just that x. Now f is saying e to what power is 1? That is 0. Anything to the 0 is 1. Okay, so for 4, we're going to solve. And to solve, we're going to convert to a log. So log base 3 of 10 equals t. And the reason I had to convert to log is because the 10 can't be turned into 3 to a power. So we have to convert it to a logarithm. Well, now just plug this in your calculator. If you have the new kind of calculator, you have a log base option in your math menu where you can actually type this little base and then type this argument. The old kind of calculators, you don't, so we have to use the change of base formula. And what the change of base does is it changes the log of any base to a log base 10 or to ln, and you can pick either one. And we always do the argument in the addict or the numerator, and then the base in the denominator. If you prefer, you could do ln. It does not matter. You could pick either log or ln, and then you're going to type that in your calculator to get the decimal answer. We should get 2.096 if you round correctly. For 4b, before you can do anything, we have to divide by the 5 of the coefficient. And I'll just keep that 12/5. And now to convert this to log form, I actually want my exponential on the left. So I'm going to move the 12/5 to the right. Now we can convert it. So the ln of 12/5 is 3t. The reason I used ln is because when you bring the base of e down, that's log base e. So now in your calculator, we're going to type ln of 12/5 and then do the answer divided by 3. And that should be 0.292. Okay, so for number 5, so for number 5a, we want to know with compound interest, how long will it take our money to double? So if we start with 5,000, that means we want to equal 10,000. 1 plus 0.08 to the t. So we can divide both sides by 5,000. Now we have to convert that to a log to solve. So I'm going to put the 2 on the right. So that's going to be log base 108 of 2 equals t. That's kind of gross. Actually, we can use one of our properties. I'm going to do this a different way. If I choose either log or ln, it does not matter which. I'm going to ln both sides because then that makes the t become my coefficient. So now we can do the ln of 2 divided by the ln of 1.08. That's where those properties that we did yesterday come in really handy. And using your calculator, you should get 9.006, so that's 9 years. Okay, so we're going to do all that again for compounding continuously. So for compounding continuously, we want it to double e to the 0.08t. We'll divide both sides by 5,000. Let me write my e on the left just because it looks nicer to me. And I'm going to do the same thing. I'm going to ln both sides. And now the exponent can come to the coefficient, or the ln of e leave us with just the exponent. And then we'll divide both sides by 0.08. And we should get 8.66 years. Okay, so now let's talk about graphs. For 2 to the x, if I plug in -2, we're going to get 1/4. If I plug in -1, we're going to get 1/2, and then 1, and then 2, and then 4. Now, a logarithm is the inverse of an exponential. So I can switch the x and y. So notice in this chart on the right, we have the y is -2, so that means the x is going to be 1/4. The y, then it's going to be 1/2, and then 1, 2, and 4. So I'll graph my exponential in red. I'm just going to do those integer values. We know we have a horizontal asymptote. That's very sloppy. Sorry. Let me try again. Okay, so there's my exponential graph. Now I'm going to do the logarithmic graph in blue. And with the logarithm, I'm going to go, let's do the whole values. So over 1 up 0, over 2 up 1, over 4 up 2. And then these fractions are going to be here. So we get this graph. And the horizontal asymptote turns into a vertical asymptote. So now to do all the properties, we'll pause the video here. You do all of as many properties as you can, and then we'll unpause it and you can check your answers. Okay, so for domain, for the exponential, x is all reals. The range is y is greater than 0. The asymptote is y equals 0. And the y-intercept is the y value of 1. It is not odd or even, meaning y-axis or x-axis symmetry. For end behavior, for the right, that's the limit as x goes to infinity of your graph. So if we look at the exponential, as x goes to infinity, the y's go to infinity. And left end behavior is the limit as x goes to negative infinity. And we're going to approach 0, our asymptote. It's always increasing. There's no max or min, and it's concave up like a cup. So now for the logarithm, the domain is x is greater than 0, and the range is all reals. And our asymptote is the vertical line x equals 0. And we actually have an x-intercept now of 1. It is neither odd or even. Okay, so for the end behavior, the limit as x goes to infinity, we are going to go to infinity. Very slowly, but it is still increasing and going up. For the left end behavior, as we go to negative infinity, this one's a little tricky. As x goes to negative infinity, does your graph ever go over here to negative infinity? No, our graph only approaches 0. So for the left end behavior, it actually does not exist because we never approach infinity. We only approach 0. The graph is increasing. It does not have a max or min, and it is concave down because it's bent down like a frown. Okay, you have to skip over a page to find the correct homework. The correct homework looks like this. It's page 27. And it's not all of them. You're just going to do the odds. All of the answers will be on Edline for you to check.